Well, welcome one and all to our meeting tonight, which is the astrophotography meeting of our group's images from our members. So Richard is going to give us a tour of the night sky, and if Richard, you can come up, we'll get you started.
Well, welcome everybody to our last meeting of 2025. Just one of the things about the December meeting is that we're coming up for the brightest time of year for stars. The reason for that is that we are now facing into the Orion arm, which is our local arm of the galaxy, whereas in the summer when we're facing the galaxy centre, and that means that we get a lot of bright stars, and just a few of them are here. In fact, most of them are actually a really bright A-type stars, because that's what the arms of galaxies are mostly composed of new bright stars, because that's where the dust and gas is. We have some exceptional other stars though. Betelgeuse, we know, is an M-type star, which makes it a red star, certainly orange. And also we have Aldebaran up here, which is another reddish star. It's not as red as Betelgeuse though. It's actually a K-type star. And if we move a little bit further over, if we come up to here and just advance the time a little bit, so we can advance the time. Stop. We get the rest of the winter constellations. Now, there are just so many objects in the winter sky that you can see quite easily that it's an ideal time to begin, whether you've got a new setup for astrophotography, or you've got a setup, you've got a pair of binoculars or a small telescope. There are just so many things. And to start this session off in the evening, you can always have a look at Saturn, which is now moving towards the west. It's still, the rings are pretty narrow. I haven't seen it myself for the last few weeks, so I haven't seen what the angle the rings are at, but I'm still, they're pretty sure they're still closed. And then we move on to the brighter constellations of Orion and Taurus the Bull. Now, there are several things that give us an insight into the depth of the night sky, but one of the most easy to look at is this little asterism here, the Hyades, and the fact that you've got Aldebaran shining there. Now, they make a really beautiful sight in a small pair of binoculars. The smallest equipment you can use with wide field of view will bring in those stars and make them, there's different shades. Some of them are yellow, some of them are white, and of course you've got the contrasting orange of Aldebaran itself. But the interesting thing is that Aldebaran is actually at 65 light years distant. It's closer than the Hyades, and the Hyades are one of the closest open clusters to the sun, but they're about twice that distance. So what you're looking at when you look at Aldebaran and the Hyades, you're actually looking into the depths of space. So you've got a dimensional sort of situation going on here. You've got 3 dimensions. And then of course we can move up to the Pleiades, which is another beautiful cluster of stars, well seen in binoculars, and also a good imaging target as well. We used to say that that bit of nebulosity that the Pleiades are actually enmeshed in was actually their birth sort of swaddling clothes, if you want to use a biblical kind of in a connotation here. But more recently, astrophysicists have always been a bit uncertain about that one, because the cluster, although it's about 10 million years old, the stars, that's a little bit, the nebula would have actually diminished by then, so you wouldn't be able to see it. So now what has been found out is that actually the Pleiades are drifting through a cloud of dust and gas, And that's why they're illuminating it, and that's why you've got a reflection nebula, and that's why it's red, because it's a reflection of the stars on the dust. Now, if you want to use a big telescope, you've got an object here. This is Zeta Tauri, and there's the other bull, the other horn of the bull. That's beta. That's gamma, zeta rather. Sorry. If you look just a little bit to the north, if you've got a really good telescope, you will actually see a dim misty patch. That dim misty patch is what's left over from a titanic explosion, a supernova, which was seen on Earth in the year 1058. And the amazing thing about it is that the only records we have are Japanese and Chinese astronomers. It was not seen in Europe for some reason, or at least if it was, they ignored it. But this star would have been hugely bright, and then what's left is the matter that's left over that's actually heavily magnetized and really quite disturbed, with lots of radiation going on from the leftover of the supernova explosion. And that is M1, Messier 1, which Messier didn't find. It was found by an English guy called John Bevis a few years before Messier started putting together his catalogue. So there's something there that you can see about the birth or the death of a star. A supernova is the death of a very, very big star, and something that possibly might affect this constellation here in the star Betelgeuse, which is a red giant. We already know that it's pretty much on the edge of exploding. And this, of course, is the constellation of Orion. This is the main stars. There's Rigel there, which is a very hot white star, blue-white star, and that is a very distant star, much more distant than Sirius, the brightest star in the sky. That's about 1,000 light years away. And this constellation, because it's the fact that it's on the celestial equator actually runs over that star there of the belt, the top star of the belt. So that means that it can be seen by every inhabited land on Earth, because literally it's on the centre of the sky. So you can see it from as I did, from Alaska. You can see it from Hawaii, and you can see it from New Zealand. And believe it or not, I've actually seen it in those three places. Believe it or not. Anyway, the fact is that it's visible everywhere. And I remember once, Jan and I were in New Zealand, and we were lucky enough to meet up with the Royal New Zealand Astronomy Society at their place at One Tree Hill in Auckland. And I noticed this guy looking at the Orion Nebula, and chatted to him after a little while, and I said to him, what, you don't come from these parts, you seem to come from Europe or somewhere like that. What do you find is really the greatest thing about observing in New Zealand? And without a blink, he said, looking at the Orion Nebula without wearing hat and gloves. So it gives you some idea of how important that is. Anyway, so here we have an area which is famed for star birth. It's an area of gas and dust, which we know is the matter of future stars. So, but also there's another point about this. The Orion Nebula is one of these things that is all things to everybody. Because if you've got a small telescope or a pair of binoculars, the thing to look at is the trapezium of stars, the four stars that make up the trapezium, and the fish's mouth, which is the part that's sometimes called the Huygens region of the Orion Nebula, because that was the part discovered by Huygens in the late 17th century. Believe it or not, Galileo didn't see it. He never noticed the Orion Nebula. So the thing is that if you go to then a bigger telescope, you see the clouds, the nebulosity much better, and you can see the stars. When you go into photography, you get a different version altogether, where the stars are missing because they're so overcome by the nebulosity of the colours, the various colours of the nebula caused by the different elements. There's also another interesting point about this. If you went to the Orion Nebula, you'd never notice it. You'd probably go through it without noticing it, because the matter that composes the Orion Nebula is actually less dense than the best vacuum obtained on Earth. There's not really much matter in it. The reason that it is so notable is because it's very thick. It goes back hundreds of light years. So it's just its size and the fact there's just so much of it that enables us to see it. Interesting thought that it's really, we're looking at a virtual vacuum. It's just a little bit less of a vacuum than the rest of space. So we come down here to Sirius, and Sirius, of course, is the dog star. It's only 10 light years from Earth, sorry, 8 light years from Earth, so it's pretty close. It's an A-type star, as are most of the stars in this area. That one is an F, that's Procyon, and of course when we come up to here, the stars in the belt, etc., are again mainly A and B-type stars. Now, I mentioned Sirius, but one of the things I would like to point out, the Orion Nebula is really good. I appreciate everyone seeing it, you can do a lot with it. But the other thing is that it has a star beneath the lower belt star called Sigma Orionis. Now, this is a quadruple star, and it's one of the favourite things I like to look at because it's like a fancy piece of jewellery. Each of the stars in the four actually has a little double star, an extra star, and they're slightly different colours. It's one of these things that when you observe the sky a lot, often the spectacular things you tend to take for granted, and it's odd things like that. And the double star, the variable star that I pointed out last month in Cassiopeia, that actually take your attention. I'm just going to move on a little bit more. Now, one of the other constellations of the winter is obviously Gemini. This is Gemini. There's Pollux, and that's Castor. They're different colours. Castor is a definitely blue-white star. It's A-type star again. And it is a double star as well. It's quite easy in a small telescope to separate. Really interesting pair to look at. Pollux, on the other hand, is a single star, but it's an F-type star, so it's actually yellowish, which gives so if you've got a pair of binoculars, you get the colour contrast as well. And of course, when we come to here, we've got Jupiter. Now, Jupiter is currently somewhere near opposition, will be, and it's currently very visible. I had a look myself a couple of nights ago, and you could see the cloud belts, and Andrew also mentioned seeing the cloud belts and the moon strung out in a line. And it's always interesting to look for that because it's an evidence of something moving in the sky, and they do change positions. And you might see, as I saw a few weeks ago, a close conjunction between two of the satellites. So there's loads of things to look at in the winter sky. In fact, the trouble is there's almost too many. But on the other hand, you've got to point out one thing, that we've got a lot more time to enjoy it because, of course, we get the longer nights. However, that does not mean that we see the sky better because we have bad weather occasionally. But if you do get a couple of nights over Christmas, do have a look at the Christmas stars. And if you're worried about Christmas being a pagan festival because it's actually the festival of Saturnalia, which was the Romans, which is where we get it from, just think of it in one way. If you're religiously inclined, that after we've got a nativity going on here, this is the birth of stars, and when you swing round to the northwest, you can see the cross of Cygnus sticking up like a portend of the Easter story. So depending on your choice, you can do that, or you can just go inside and have a glass of mulled wine. So with that, I'll sign out. Thanks so much. Thank you.
So now we've got our members' images section, and some of the members are here, and some couldn't make it, so they've just given us a few notes to read, and I hope I can do them justice, so it'll fall to me to do that. So first up is Antonio's pictures. As Richard talked about the Pleiades, here you go. This is the Pleiades. And this is Antonio's picture taken. He took it from Roberto in Italy, where he is from originally, and he's actually gone back there for Christmas, so that's why he's not with us. But he's written a few notes here, and I'll read them to you. The Pleiades, or Seven Sisters, is one of the most striking objects in the winter sky. This star cluster has been depicted since ancient times. Now, long exposure images show us the beauty of the clouds of dust surrounding the Seven Sisters. As you can see, these are the clouds that Richard was referring to, and reflecting the beauty of it. It is a striking object, and when you image it, it's even more striking. So that was Antonio's first picture. The next one he's got here is the M81 and M82, the Bode and Cigar galaxies. So Antonio's given us this image for February. He was actually very good. He gave us an image for nearly every month of the year except July. So it shows you how dedicated he is to his astrophotography. So in this particular one, they're called the Bode and Cigar galaxies. So this is Bode's galaxy at the top, and the Cigar M81 at the bottom. These are two interacting galaxies, and they're about 12 million light years away. And they're situated in Ursa Major. In this picture, we can even see the details of the red hydrogen star-forming regions within the Bode galaxy. So that would be this area up here at the top of the image. There you can see these red areas are star-forming regions. And these have an impact on the smaller galaxy down here. This image was taken at our observatory in Flodden in February 2025. We had a partial solar eclipse, and Antonio used our Society Lunt telescope to take this image. It's the sun's surface with its flares, as you can see, but also you can see many of the surface features or granulation and sunspots and areas of activity, which I think we'll find out a little bit more about later on. These are AR areas, they're called, active regions, and each of them is given a number so we can identify the different sunspots as they arise. So this was used by Antonio to capture this. It's a hydrogen alpha telescope, and you see features that you cannot normally see in white light. The next one up is the Sombrero galaxy, and it looks like a spaceship just hovering in space, doesn't it? One of the key features of this galaxy is the central core, very bright, massive stars, and then the dark dust lanes around the outside where the light is obscured. It's 31 million light years away, and this galaxy has at its center a supermassive black hole. That's what holds the whole galaxy in rotation. And its mass is 1 billion times that of our sun. He took this image from Roberto in Italy again in April 2025. You probably can't see it, but there are other galaxies in the picture as well, very faint galaxies. So one of the things that you'll notice when you start astro imaging, many of the artifacts that turn up in your images are actually distant galaxies as well. So that's Antonio's Sombrero galaxy. This one here is the Hercules cluster, a very well-known star cluster. And basically it's the city of stars. Unlike the galaxies you've just seen, these are a group of stars that when viewed from our direction just looks like a snowball of actual stars. There's approximately 400,000 stars in this cluster, and it's on the outer edges of our galaxy. so dense that stars actually collide with each other, and that's very unusual, and form younger, bluer stars. It's one of the oldest objects in our galaxy at 11.7 billion years old. Antonio imaged that from Flondon, and again you can see background galaxies, like there's one here and one up here as well. So this is unusual to be able to image something that's so distant. So to give you an idea, the universe is reckoned to be about 13.5 billion years old. So that's very near the beginning of the universe, that light that you're receiving in Flondon. The picture they had for June is the Crescent Nebula, and many people have imaged this in different ways. Antonio has chosen to use a different palette. So a palette is the way that you assign the different colors to the different chemicals, the hydrogen, the oxygen, and sulfur, etc. And this is an emission nebula where the gases are expanding all the time. And here the red hydrogen and blue oxygen can be seen. And it's ejected by the central star. And it glows bright due to the interaction with the solar wind from the same star. He imaged this in Flondon as well. He spent a lot of nights up there. I must say he's a very dedicated astro imager. Don't know how he goes to work in the morning afterwards, but he does. Many of you that go up to the Flondon area for imaging will know that when you get a clear night, you stay with it until you get those hours clocked up on your image. And that's what it's all about, is building up enough light on your image so that you can form something spectacular. And this is no exception. This is Antonio's Seahorse Dark Nebula. You can see here it looks eminently like a seahorse. And what this is a cloud of material that's between us and the background, so it's blocking out the light coming from the background. And these types of dark nebula are notoriously difficult to image. It takes a bit of skill and a bit of manipulation with the processing afterwards to actually get the image very clear. So this image is clouds of cosmic dust that we see, not for the light they emit, but for blocking the light from the stars behind them. This makes them very complex targets to image, as I mentioned, and it does require dark skies, patience, and, as Antonio puts it, a solid technique. So you've got to be very disciplined to do this with doing all the proper processes that follow imaging something like this. He took this particular image from Italy in August 2023. And you may look at this and think that looks eminently like a shark. There's the shark's head and its teeth, and there's its nasty looking eye. And that's actually what it's called. It's called the Dark Shark Nebula. And again, this is an area of dust that's obscuring the background so that we can see it as a dark nebula. Again, it's quite a difficult target to actually acquire. Antonio describes it as a few things match this eerie, faint beauty of a dark, cold nebula, especially with such an evocative shape. Imaged from a dark location in Wales. In fact, it was Tregaron in Wales, and he took that in September 2025. This is quite a striking image of the recent visitor to our system. It's Comet Lemon. And I would invite you afterwards to come and look at a closer inspection of this image, because Antonio's managed to capture the twists and tails that you probably can't see from back there on the comet tail. And again, this is not an easy object to image because you can imagine the comet is shooting through space, which means that if you're focusing on the head of the comet and the tail, the background stars are moving. So you actually have to employ a technique of imaging the stars as well as the comet separately, and then putting them back together to give that image of the comet actually whizzing through space. And it involves a lot of skill, because you've got to mask out the main part of the comet and then superimpose the stars on top of it, because if you don't do that, you'll find that stars are poking through in places that they shouldn't do. But again, this is the last time this was here was 650 AD, and it'll not be back for another 1100 years. So if you've missed it, I'm afraid that's it, you've had it. It's called Comet Lemon. You might know why this is, but there's an astronomy facility at Mount Lemmon in Arizona, and it was the guys at Mount Lemmon, one of which is a very famous astrophotographer called Adam Block. He operates from there. They were the first to detect it and image it. And this was only 24 minutes of an image, and it was taken from a high altitude of 1,300 meters in Mount Zugna in Italy, near where Antonio comes from. He comes from the Dolomite area, you might know. So next up, we've got the Bubble Nebula, and you can see why it's called the Bubble Nebula, because of its bubble shape in the center. It's another emission nebula, and this cosmic bubble of gases is expanding from a central star, which is in here, due to the radiation from that star. And that was taken from London in September by Antonio. This one is called the Orion and Running Man Nebula. And they're just giant glowing clouds of gas, which are a cosmic nursery for stars. So these are star-forming regions, particularly around the boundary areas where you see there, where you get collisions. And as you know, all stars grow up from cosmic gases congealing and coalescing. And once the star forms, then you get protoplanetary disks forming as well, which means that you form planets around it. And in fact, the Hubble Space Telescope has imaged solar systems being formed in this very area. So the recently formed stars at the core make these glow very bright, and they're visible with the naked eye in the middle of the star, Sword of Orion. So you can see some of that with the naked eye or with a pair of binoculars. Richard loosely referred to that at the Sword of Orion, just below the 3 stars of its belt. So next up, we've got Thomas Ramage. Thomas is here tonight, yeah? No? He's not made it, has he? Okay, I thought Thomas was coming here tonight. Never mind. I shall give you a quick run through some of Thomas's images. This one, I get no prizes for guessing it. It's the Andromeda Galaxy. I can't tell you very much about it, but Thomas took this using a remote telescope, and you can see there's a lot of detail here in this, and it takes several hours to build it up. We're talking about anything from 20 to 40 hours to do this. But using a big telescope that's remote, you can cut that time down, so my guess is that he probably did it less than in 10 hours. This one is the Elephant's Trunk Nebula, and the Elephant's Trunk part is here. He imaged that with his own equipment, I believe, here close to Watford. Next up, he's got the Hamburger Galaxy, and again, he used a remote telescope to acquire this image. So this is one of the things that's becoming more prevalent with astrophotography. It's an expensive business to own your own kit. It's also quite expensive to hire remote telescopes, but there are some very good sites that allow you to do that, and you can collect the data, which is your data, but also many of these sites allow sharing of data, so you can download images yourself and then process them and make your own images. It sort of removes you slightly from the immediate imaging of doing something from your own backyard, but nonetheless, it's a very valid way to do astrophotography. In fact, one of my first astro images was one acquired at Mount Lemmon. I was out there, I happened to be on a business trip, and I never felt good enough to present it as an image of mine, because actually the guy that took the image did all the work and said, here's the data, you can make your own image. So I felt that that wasn't, it was a step too far for me, but again, remote imaging has its place, and it's becoming more prevalent because there's such good quality equipment out there now these days to do it. So that's the Hamburger Galaxy, and you can see, unlike some of the other galaxies you've seen, it hasn't got that dome of central stars. It's more evenly spaced. And again, the dust lanes on its edge on, showing that there's a lot of material are still to be formed in that galaxy. This one is called the Liberty Galaxy, and again he used a remote telescope to image that. I don't know too much about it, so I can't really speak on that. It's a shame he wasn't here to tell us a little bit more about it. But I guess, again, the same thing. You're using telescope hours to download images, and then you're processing the data through the processing tools that you've got. This one should be known to a lot of our astro images, although it's turned on its side. It's actually called Thor's helmet. And you can see, for example, here, these are the horns of the helmet, and there's the helmet. And again, he acquired this using remote telescope. And if you look closely at the image, which you should do afterwards, there is a lot of detail here, which means that it's a very long exposure. And there are artifacts of dust lanes visible all around it as well. This one is called the Californian Nebula because it looks like the coast of California. And again, Thomas has imaged this from his own equipment back here in the UK. And really, it's just a cloud of gas that is an emission nebula that can be imaged fairly easily by most people around. I think he used a DSLR in this case with his telescope to actually take this image. This one is called the Elephant's Trunk Nebula. You saw a little bit of it earlier from a wider shot. This is a more close-up image. And again, I guess he's cropped and imaged part of this using the processing tools that he has. This one is fairly well known. It's the Rosette Nebula because it looks like your typical rosette flower type of a thing. And again, an emission nebula that is fairly readily imaged by most people. The challenge is getting the balance between the dark areas and the light so that it doesn't get blown out and you can see the detail. Next up then we've got Ronnie. Is Ronnie here?
Hi everyone. So I started this year being interested in astrophotography, and on the advice of various members of the astrophotography group, I decided not to spend a lot of money, and I went for a C-Star S30, which is kind of beginner's toolkit. It's about the size of a toaster, very portable. This is the Pleiades, which we've already seen twice, and you can see that although the image is perhaps not as filled out as the one by Antonio, there's quite a lot of detail there. It's just over an hour and a half. You set it up, it's very easy to set up. I've got an equatorial mount, set it up in the garden. You control it from your phone or an iPad, and I take the images once they're finished. I process them in something called Graxpert, which again is something recommended by the astrophotography group, and then finish them off in Photoshop just to clean them up a bit. So it's one of my attempts from last month when we had a couple of clear days, and you can see that the blue, these are the younger stars there. So that's the first of the three images we're going to show. I think everyone knows what this one is, Andromeda. Obviously this is our nearest neighbour, 2.5 million light years away. Again, that's 2.5 hours worth of photography. What's great about the C-Star is it takes 10-second, or you can set it to different choices, but if you do it 10-second images, which is what they recommend, it's very good at processing out anything where there's a plane or a satellite or a cloud. So you get something fairly clean there. I think we all know that in 4.5 billion years' time we're going to collide with Andromeda, but we don't need to worry about that too much. But again, there's not as much detail as the one that we just saw, but it's a good start, and I'm kind of pleased with that. And then the last one, so this is a bit further away. It's another spiral galaxy. It's triangulum. It's using the same technique, again, just over 2 hours. This one I took, I was on holiday in France, and because the kit is so portable, it's literally that size. I just set it up outside and pointed it at a much clearer sky than we get here. And in fact, it was a real joy being there. Every night you could just
warmer
see.
as well.
It was warmer. And although from a Bortle factor, it wasn't that much better than Flaundon, it just seemed that way, and you had much more access to the sky. And again, it's cleaned up a bit in Graxpert and then processed in Photoshop. And I just want to say thanks to any members of the astrophotography group who are here, because they've literally held my hand throughout this whole process. Because for a complete beginner, it's quite hard to work out what to do, what to buy, and so on. Antonio did give me a massive shopping list, but I think that'll have to be Father Christmas next year. Thank you.
Very good, thank you. Thanks, Simon. Excellent, and the Sea Star that Bronnie used is the S30, and I think from memory it's less than £400, which is...
I saw today it's £369, they've got a discount on.
Wow. And it is actually an amazing piece of kit for what it does. But we do have other members that use the slightly bigger version, the S50. We'll see that later. So next up is Andrew Lane.
So I've got 3 images to share with you. They were all taken using this equipment which Antonio, as like with Ronnie, gave me a shopping list, and I'm afraid I did part with a sum of money to purchase it. But yeah, very, very pleased. Basically, this is a William Optics GT71 refractor, and at the end it's fitted with ASI 533 Pro color camera. The mount, the AM3, that's the ZWO mount with harmonic drive, so you haven't got the big sort of weights to balance the camera, to balance the instrumentation as it's moving and tracking the target objects in the sky. This particular image is the Rosette Nebula, which was processed as a result of 63 180-second exposures in November. And for this image, Antonio kept saying, you know, use a filter, and it has an Optolong dual band L Extreme filter, so you're filtering out a lot of the other light and that you don't want to be seeing. So again, you can see some good colours there. I think the thing that's sort of interesting is this is like a huge star forming region in the centre. I'm always interested by a little bit about the sort of the physics and the what's sort of going on to create those images. I'm sure many of you know that this is I made a note of it. Yeah, basically it's a huge star forming region, 5,000 light years away, and the diameter is 100 light years. It can be seen near Betelgeuse and the Orion Nebula. This is the Orion Nebula, and this is a result of capturing 28 60-second exposures of the Orion Nebula in February earlier this year. And then there must be another one. Eastern Veil Nebula. It's a cloud of heated ionized gas and dust in the Cygnus constellation. This is one of the visible portions, which is called the Cygnus Loop, which is a supernova remnant. Yes, so this is the one where I thought it was quite interesting. NASA calls it the cosmic shrapnel left over from a star that exploded several thousand years ago. Only the most massive stars end their life as a supernova, and these explosions are responsible for creating all naturally occurring elements that are heavier than iron. So everything that things like copper, mercury, gold, and lead, that's all produced from events such as these with that supernova. And that's it. Thank you.
Thank you very much, Andrew. Suzanne, and she's taken some images using her Sea Star, so we'll get Suzanne to talk to you.
I've got a Sea Star S50, which I was inspired by Phil at the beginning of Christmas last year, and saw a Sea Star and just went, I want one. So I can't believe I've had it for a year now, almost a year, wow. So all these images, I think I've taken them from home in Hemel, and you can see I've done an M52 and done it for 68 minutes, and I take it on holiday, so it's been to Shaftesbury, and it's going to go on holiday. It's going to be a staple every time I go on holiday now. So apologies, I can't give as much information as some of the other people can talking about images, but I find an image, I like it, and I'm going to capture it. So it goes out in the back garden, I set it running, and then periodically check it. I do get the occasional satellite or plane running through it, but and I've just realised I've got the bubble at the top right-hand corner there. Oh, 2 for the price of 1. So how do I... Oh, yeah, oh, that's cool. Likewise, yeah, it was actually in Hemorts at home. And I've done a little bit of editing, but not a massive amount, because I'm not that good with editing on computers, but I still like the pictures. So again, that was taken at home, and I tend to find out which one is most exposed, most visible, because I've got the house and trees and stuff. But yeah, I have no idea what it is. That's the barbell. Didn't run it for that long because it kept having stacking issues, which is why it's only run for 21 minutes. But I still think it's cute, and there's a little tiny barbell in there. Cool. So this one again, I thought that was a really pretty image, and then left it running at home. Apologies, can't explain much more information than it's a pretty image, and I liked it, so I got a photograph of it. Sorry, next one. This one, I will admit, this is taken on my phone, because Mum, oh, I've actually got an aeroplane.
Yeah.
Neat. Mum went to put the dog out for a wee, and then suddenly called my name and said, "Get out here, because the moon looks amazing." So I just grabbed my phone and rested my phone against our washing line, which is a concrete post about 9 feet high, and rested my phone on that, and that's the moon with a ring around the moon. I've got some other ones where I put a selfie of myself in it to get the image, but I thought, no, that's the one I'm going to put on there. I don't think you really want a photo of me doing that. But yeah, I thoroughly enjoyed it, and I love my sea star, and it's a staple. Oh no, there's the bubble. My sea star comes on holiday, and it's a brilliant little thing. Yep, it's in a little box, and you get you get a cable, you get a sun filter in it, and I've now got a little mount that I got for Christmas that sits on the side of the battery pack, and so it'll actually charge it as it spins round. Sorry, you put a charging pack in it, so it doesn't run out of power. But yeah, that's the bubble, which I ran for longer that time, and no, it's fine. It's fine, Sean.
Move on, yeah.
Yeah, and this is my attempt at the ghost, and every time I try and get it, I always have clouds. I think I'm jinxed with this one, but I really do like that triangle shape effect. Love that. So that's kind of my target one, to try and get a better image. But yeah. I think it's a brilliant piece of kit, and I do recommend Sea Star. Anyone starting it out, it's easy to use, it's brilliant, you get some great images. And whichever that... Yeah, sorry, another pretty images, not much to say apart from it's a nebula and it's pretty. Cool.
Next one,
yeah, I think.
Thank you very much,
That's
Suzanne.
all right,
yeah.
You're welcome.
So next up, we've got some images from Stephen Helsiger. Stephen isn't here tonight, so he's just given us a few notes to talk about some of these images of his. Stephen was one of the first people we had in our society that used one-shot colour cameras, OSC they're called. And I was amazed when I saw the quality of images he was taking with just a colour camera. Because up until that time, we'd traditionally been using mono cameras with filters, and it's a laborious process, anyone that's gone through it, because you've got to take 3 sets of images and you've got to calibrate them all. But Stephen turned up with the one-shot colour cameras, and he's produced some amazing images. So this is one of the Rosette Nebula, and it looks very different from the Rosette image you saw before, and that is because Stephen has used a different colour palette to bring out the features that he wanted to highlight. But there's a lot of detail in this image, and basically the Rosette Nebula is also called Caldwell 49, and it lies on Monosaurus, the constellation close to Orion. The central open cluster is of young stars, NGC 2244, and the emission nebula lie at the distance of 5,200 light years away from us. And the nebula measures roughly 130 light years across, so fairly decent size. But again, you probably can't see it, but there's a lot of detail in this nebula. from the dark dust lanes to the light, and the boundaries between different areas of the actual nebula itself. Next up, he's got one, and it's called the Flying Bat Nebula. I hope you can see that. Sometimes people can't see the image, but these are the wings of the bat. There's the head of the bat, and there's the other wing. That's the tail. So it's called the Flying Bat Nebula, and it's in the eastern veil of the Cygnus Loop. You saw the part of the Cygnus Loop veil, of the eastern veil previously with Andrew's image. It actually spreads out in a very big circle, and so it's imaged quite often in different areas. So this is the part that Stephen is imaged. He used O3, sulfur 2, and hydrogen alpha to actually narrowband image from RGB data of the star as well, taken on a recent star party at EI in southern Spain. Again, this is a telescope facility that you can rent out the telescopes there, but quite often many of our members take their own telescopes there as well. And it's a completely different, more complex workflow than the one-shot color that you saw in the previous image. So he's using separate processing, as I say, the oxygen 3, sulfur 2, and hydrogen alpha to form this image. So it looks a bit eerie. The next one up is Crescent Nebula, and also a planetary nebula. So the Crescent Nebula is the larger one here at the top, and the planetary nebula is this bubble down here. Quite a difficult object to capture, and getting the balance between the different intensities of light that you're capturing is quite difficult. Technically this is a difficult area to capture. But it's a planetary nebula taken over 2 cloudless nights, which are very unusual. And he was in North Wales for this, and it was taken last week, in fact. The smaller one is called the Soap Bubble Nebula because it looks like a bubble from suds that you would perform with soap. This one's called the Dark Shark Nebula, and this is the head of the shark up here. There's its eye. And quite often you'll see this image as well taken a different orientation where the head is reversed. It's almost like a mirror image, and the head is on this side. It really depends on the equipment you're using and whether the image is actually mirrored or not. But again, this is a notoriously difficult object to capture, and it's really made up of interstellar dust, and it's dark, and that's why it's difficult to see. One of the challenges of astrophotography is you're focusing on objects that you can't see in the dark, and got very little light coming from them to actually indicate that you're actually on an object to start with. So quite often when you start imaging something like this, you don't actually know that you're going to capture the image you're after. You may have to reframe it. So with dark nebula like this, it's very difficult to get that right, so he's done well here to do it. So the Dark Shark Nebula is made of interstellar dust about 650 light years from us. It's so thick that it hides most of the light coming from the stars behind us. It is very faint, as I mentioned, and difficult to bring out the background due to how dark things are. This one you should know as well, the Helix Nebula, a very well-known object in the sky. It looks like an eye in the sky. In fact, I've heard it referred to as God's eye. But he imaged this in Spain, and it's one of the closest planetary nebulas to us at about 650 light years away. And it's located in the constellation Aquarius. He used PixInsight to reprocess some of the data for this to highlight the really specific blue in the center and orange around the outsides. And in fact, the shock wave coming out from the star that originally exploded or to cause it in the first place. The next one is up. We've seen a picture of this before, but it's M33, the Triangulum Galaxy. And Stephen combined data from 2 telescopes and 2 cameras from his own back garden to form this image. He captured part of it in 2024 and the rest of it last week, in fact. The Triangulum Galaxy is a spiral galaxy 2.73 million light years away from us, and it's in the constellation Triangulum, hence its name. But you can see it is a spiral galaxy, a very common type of galaxy indeed, and it's nice to see different aspects of the orientation of the galaxy compared to, say, the Andromeda Galaxy and like Bode's Galaxy and so on that you saw earlier. It's the third largest member of the local group of galaxies behind Andromeda Galaxy and the Milky Way. So next up, we've got an unusual object here. It's called Melotte 15. And some of you would know that the region that this is in is the Heart Nebula. This is actually the heart of the Heart Nebula. So at the center of the Heart Nebula is this Melotte 15. And it's a very interesting region of activity. You can see all the dark lanes of material that show up all over the place. And then you've got the bright areas, the star-forming regions as well. As you know, dust lanes actually form into stars eventually. So it's a very active region, this. So it's an open star cluster located at the center of the Heart Nebula. And this young cluster is a source of intense radiation from its massive bright stars, which sculpts out the surrounding gas and dust lanes forming the nebula. And it's located about 7,500 light years from us in the constellation Cassiopeia. He took this from his North London home. It's a Bortle 7, so it's not great, but on the 8th and 9th of November. It's a very interesting image, and again, if you have the opportunity to look at some of these close up, what I suggest you do is that when we record the video, you go on the YouTube website and have a closer look at these images. You'll see them in much better detail than you can from further back there. Stephen has been imaging Saturn for quite a few years, so this is actually 6 years of Saturn's changing rings. He started in this particular image in 2020, and then he goes through to 2021, 22, etc., down to 2025. And as you know, if you've observed Saturn recently, the rings are pretty much edge on, and it's not nearly as spectacular when the rings are open. But the other thing that Stephen pointed out in this is that when he started imaging, his images were quite fuzzy, but still very, very good for planetary imaging. And as the years progressed, his images have actually progressed also in clarity. And that's partly due to his change in workflow and also using different equipment. So next up, we've got Andy Pennell. Andy submitted some images, which I will talk you through as well. Andy's created a variety of images for us. The very first one is a star trail from Tring Park. And this was 2 hours of stacked 1-minute exposures on a Canon 6D, 24mm lens with f2.8 and ISO 100. So pretty standard settings for a camera like that. But it takes patience and time to build up an image like that. You know, 2 hours of sitting there watching the sky go by. I know some of our guys like Ben has produced motion pictures of those where you do stop motion and you get an image building up there, quite spectacular as well. But this is a very nicely presented image. It's well composed with the pole star right in the center of the post. And that was intentionally, it took a little bit of research to find the place where these are going to happen. So obviously Andy spent some time researching that as well. Next up, we talked about this earlier, it's the Heart Nebula. So this is the whole of the Heart Nebula. Melotte 15 is in the center of that. And this is Andy's version of the Heart Nebula. This took him 13 hours to capture this image. And he used 2 dual band filters as well. His telescope was a Skywatcher 50 AD, so a 2-inch telescope, not a huge telescope. But it's a very nice image. And he's managed to balance the light and dark areas very well here and bring out all the features that you can see right around the whole of the image of the Heart Nebula. Again, this is another take on the Elephant's Trunk Nebula. This time Andy's used a bigger telescope, a 200 millimeter, a Skywatcher, a 200p it called, and it took him 4 hours of gathering data for this using hydrogen alpha, oxygen 3, and using L ultimate filters as well. When you get into astrophotography, you'll realize that you have to introduce some filters to get rid of unwanted aspects of light pollution and other things that you want to cut out so that you focus on the main areas of gathering light from the particular target you're looking at. So Andy's done that very well here. So that's the Elephant's Trunk Nebula. This is another take on the Crescent Nebula. You've seen an image of that earlier. And again, using different palette, he's got 5 hours of hydrogen alpha, O3, and using the L ultimate filter again. And this time it's again on his 200p Skywatcher, the 200 millimeter telescope. Again, we're looking at the Andromeda Galaxy, M31. And this is 7 hours of imaging to produce this image. And it was a collaboration between himself and Gus Hodge, one of our other astro images. This time, Andy used a RedCat 51 telescope for that and a Skywatcher 50 ED. So he's used a variety of telescopes and different data from different sources. And the trick here is, you know, when you get data from different sources, you've got to align it. And there's a bit of an extra process in doing that. But it shows you what's possible. A collaboration between different people can build up the hours, which gives you far more detail than you would normally. So that's actually a very good image of M31. And for 7 hours, I think he's done very well to do that. One of the problems here, again, is that the center is very bright and the dust lanes are very dark. So he's managed to get the balance pretty well on that. Again, it looks better on a computer screen than it does on a projected image. And I encourage you to go again and look at the images again on YouTube once we've uploaded them. This one is the Fireworks Galaxy. And he spent 3 hours on this target. There's a lot of nebulosity around this, as you can see. And it's unfiltered, and he used his Skywatcher 200p again for that. So we're looking face on to the Fireworks Galaxy, pretty much. Again, they're all spiral barred galaxies, as you can see. It's quite impressive to be able to capture these things. Next up, he's got the Wizard Nebula. And Andy's time spent on this was about 4 hours, and again he's done very well to capture the data and then process it, because again you get these bright areas that tend to burn out everything else. And when you're capturing the nebula, you want to pick up the nebulosity without making the background stars too bright. So there's a bit of an art to actually getting the right combination of data and processing it appropriately to be able to do that. So this time he's got 4 hours with hydrogen alpha, O3, and using the L ultimate filter again, which is an narrowband filter that is very common to astrophotography. And I think this is his final one. It's the Milky Way. And again, good composition. You can see that he's taken time to choose his location. This is on his Canon 6D 24 millimeter lens, and 20 15-second images to produce this. It was at f2, but this time pumped up the ISO up to 6400 so he can actually pick up the Milky Way. So obviously it's very difficult to see the Milky Way here because of light pollution. So I think Andy took this in Oxford somewhere. It hasn't actually said, but I believe he did. Maybe someone else knows where he did it, but I know he's into cricket, so that he's even placed a cricket ball there. So maybe that's left over from the Ashes, I don't know. Anyway, a very nice composition, nice image, and you can quite clearly see the Milky Way, which is looking in towards the center of our galaxy. That's why it's got so many stars in it. And there you go. Next one up is Russell Johnson. So Russell is not able to be here tonight, and he's just submitted one image, which is of the moon. And it's a monochromatic image, so it's not a color image, but it captures the moon very well indeed. And again, he's managed to get balance the high, very bright areas of the moon against the dark seas of the Mare. We've got Tycho here and Copernicus craters very clearly visible. One of the interesting things I always find about the Tycho crater is if you look at the striation lines, they stretch almost halfway across the surface of the moon itself. So that must have been a hell of an impact when that happened. This is the full moon taken on the 4th of December. He took it as a video using a mono camera. And a 6-inch telescope, Skywatcher Newtonian telescope. So there were 3,072 frames, and then they stacked it using AutoStacker 4, then processed it in AstroSurface and Affinity Photo to get the final image. But it's a very nice, pleasing image, and for those of you that are doing images of the moon, again, the detail is very good, the contrast is very good, so he spent some time processing that properly as well. So that's the full moon from the 4th of December. Next up we've got Thomas. Thomas is here tonight, so I think Thomas is going to present his images. So I'll get up Thomas's first images and he'll talk you through them.
Thanks. So just a few images I took, sort of a couple last year and a couple this year. So this one was with a new SWHAS ASI 174 monocamera with a hydrogen alpha telescope. So it lets through a very specific wavelength of light that you need it's best to use a black and white camera, and then it was processed in AutoStacker. I forget now how many frames I took in the video, and then colorized it with a program called AstroArt, which is also used for deep sky image processing. And there's a few, don't know if they're visible, some filaments on the edge of the disk. And the sun was quite active in, I think it was from June last year. So I've labeled the active regions. I looked up to a particularly large AR 3697 near the center of the disk. And yes, quite a lot to look at there. I did try to take one of the partial eclipse this year, back in March. Unfortunately, it was a bit cloudy and the image processing didn't really do it justice. So this one's also from North Norfolk. I quite often go up to the North Norfolk coast. My brother lives in Norwich, and so we travel up there. He doesn't really do astronomy. He likes going to the seaside, and I think in June they have a beer festival, so that's the attraction for, well, both of us, in fact. This was about 11 o'clock, and we were enjoying the sunset, and I looked a bit to one side from, I guess west is to the left of the image, and I saw this lovely band of noctilucent clouds. I thought, it's really bright. It's you can see some typical clouds that are much darker because the sun has already gone below the horizon, but the noctilucent cloud is much higher altitude. Not sure what the star, just looked up, there's a couple of stars, but it was really amazing to see how bright and the sort of structure. I'm not really sure what causes these swirls, but it's really, really amazing to see. So another Star Trails video, also from Norfolk, I think in the Spring Star Party this year. So about half an hour worth of exposure, although unfortunately the lens actually dewed up, so the trails sort of tail off. Wasn't quite intending that, but it's come out okay nonetheless. And I think that was f5.6 with a Canon 700 SLR camera on a tripod. So this is the Cygnus region. So that's Deneb. And then the wings of Cygnus mainly. I was keen to get the North American Nebula, which is one of my favourite reasonably bright deep sky objects. Unfortunately, it was quite high up at the time. It was taken in June, so obviously the sky doesn't get really dark only about 1 or 2 o'clock in the morning. And Cygnus was quite high up. My tripod doesn't allow the camera to go vertical, so unfortunately the best I could do was to get the North American Nebula at the top of the frame. But nonetheless, quite pleased with how it's come out. There's Gulf of Mexico and the outline of North America. And I think it doesn't really show on the this colours, but if you take the negative image, so it's essentially black stars on a white background, I think it's somewhere down here is the Veil Nebula. You can just see a little crescent shape. Doesn't really show, unfortunately. But and then obviously the band of the Milky Way. Albireo's just off the side of the picture. It's a really nice area of the sky just to enjoy with binoculars in the summer. And so then on to something completely different. This is a kind of science project I'm interested in for taking spectra of the sun and hopefully for some stars. And I've been interested in spectroscopy for a few years, and this is a current project that's a high-resolution spectroscope, so it actually only, the dial tunes in to particular wavelengths of light which are labelled, so hydrogen alpha in the red, and sodium lines aren't actually marked, hydrogen beta, and then calcium H and K in the, just where it goes off into the ultraviolet. And this one is actually a design that's, you can find it on the internet. It's a French astronomer called Christian Wheel, who designs and builds these spectroscopes. And this is actually a 3D printed kit, so you can download the parts. Some of these are standard adapters. This is a helical focuser. And the other parts you can either print yourself if you have a good 3D printer. In my case, I couldn't quite justify buying a 3D printer just for a spectroscope, so I bought the parts ready printed, and it took me an afternoon to put together. It's not, surprisingly, for an optical instrument, it's straightforward to construct. For a sense of scale, this is a little fluffy bookmark. So this descent goes onto the telescope, and there's a lens. It's a classical spectroscope design. Has two lenses, so one for the light goes through a slit, and then it gets focused onto the reflection grating, which is in the main part of the handle, sort of dial, and the tilt of the grating adjusts the light, the colour of the light that's channeled through another lens, and then the camera goes on the end. So I got a ZWO ASI 664 camera. They'll have sort of numbers. I don't think the numbers really mean much. I think maybe bigger numbers are larger sensors, but the 664 is a colour camera. It's quite good for planetary imaging, but it also gives nice results with the solar spectrum, which you can do in daylight. So I can sit in the warm, point the spectroscope out through a window. And this is the hydrogen beta. I think that's hydrogen beta at the top. And there's quite a few other lines visible, which are mainly, I think, neutral ion in the sun. And quite a lot of them are atmospheric, water vapour and oxygen. Then I moved to the red. This is the well-known hydrogen alpha, often emission line in nebulae, where the light is reflected by gas that's around a bright star. In the case of the sun sun itself emits basically white light, and then the atmosphere of the sun that's absorb some of the white light as it comes towards the Earth, well, the sky, effectively, and reflects off cloud and what have you. So the hydrogen line, because there's lots of hydrogen in the sun's atmosphere, forms this nice deep absorption line, because most of the hydrogen alpha gets absorbed. And I think one of these lines is a neutral ion line. There's also some water vapor absorption, which is in the Earth's atmosphere rather than the sun's atmosphere. And then finally, the two sodium D lines. So for those, remember the old orange street lights, they used sodium vapor to form the light, the orange light. And so they're known as, I think Fraunhofer discovered them in the 19th century. They're known as the sodium D1. I think D1 is the redder line and D2 is the line on the green, higher frequency, higher frequency, shorter wavelength, end of the spectrum. So this covers about 12 nanometers from top to bottom, and the lines are at about 500, I think it's 589.0 and 589.6 nanometers. And the line at the top is a neutral calcium line. So the sun's atmosphere, you'd think it would be dominated by hydrogen and helium. The hydrogen is quite apparent, but the helium, because it's not hot enough to ionize helium, is not so visible in the spectrum. And a lot of the sort of forest of lines are from neutral metals like iron in particular, that has lots of different electron transitions around its atom. So I'm hoping to explore some bright stars over the winter, and so watch this space. So thank you very much.
Thanks very much, Thomas, for that. So next up, we've got some images by Philip Steed. Is Philip here tonight?
I'm another C-Star user. I've been using it for about a year. I'm a beginner, like many people. All my astrophotography is done from my back garden, which is severely light polluted, especially from my new neighbours who seem to leave their lights on all the time, which has become very annoying. But I battle on, and I've got a couple of images tonight. The first one is of the Bubble Nebula, which I've taken several times before actually, but I've been going through the process over the last few weeks with Romy over here and Andy and Gus, who I need to thank for trying to learn Serial, which is a very painful process, if anybody's been through that, and Graxberg as well, and a bit of Photoshop. So this is my first image that I've ever processed from the data from the C-Star, and it really does make a big difference when you actually start to process the actual raw data. We've seen this image several times tonight. It's one of my favorites, actually, the Bubble Nebula. It's a beautiful nebula formed by a massive star, obviously at the beginning blowing out fast-moving gas, which creates this shockwave and this gorgeous bubble in the middle. So that's my first ever image done with Serial. The next one, I shot this one last week actually, and it's the North American Nebula, or part of the North American Nebula. Again, using the raw data, I managed to quite successfully process this one. And I also liked when you actually split the stars from it, you can actually create images without stars as well, whether you like them or not. I found this quite beautiful, and it was quite a surprise to me how lovely it actually looks without the stars. In fact, I think I prefer it to the one with the stars. But that's my second image ever processed in Serial and Graxberg, and it's incredible what a difference it makes from taking the raw data from a C-Star and actually processing it, as long as you can have a good data in the first place, which is very difficult to get in Watford. But anyway, I think next year I'm probably going to have a few more images and a year of using Surreal and Graxberg, hopefully I will improve more. So there you go.
It's interesting to see the different technologies used, and certainly the C-stars seem to be a game changer, because what it does is allows people that have little or no real previous experience of astro imaging to actually take very decent images very quickly. So it's a great step up to do that. And as Philip demonstrated here, gathering the data is one part of the process, but the actual, I think often the bigger task is, once you've got the data, how to manipulate it to produce an image that you want to show specific highlights. And finally, I don't know if Jared is with us tonight. Is Jared here tonight? Jared made a sundial. You know, Jared did the human sundial in King's Langley. I don't know if you've ever visited that, but it's basically near the cricket ground, where you stand on a spot on the ground, and your shadow is actually the needle for the sundial, and it works very well, actually. You should do it on a sunny day. Not winter, obviously, is not great, but he's taken to building this one made out of wood. And he cut up some pallet wood, glued it all together, and the hour lines were cut by hand with a router. And he did this at Decorum's repair shed and got lots of advice, because he wasn't a woodworker. And he had very little prior experience of this type of thing. But he hopes to be able to make it so that he can sell this. Obviously, it needs to be weatherproofed if it's going outside. But it's an interesting thing. And if you need to know about sundials, Jared is your man. So hopefully we'll see him back here again in the new year. So I think that pretty much concludes our images for tonight. Thank you ever so much for attending. We appreciated you coming out in these winter nights. And we hope that you've seen something inspiring. And if you want to know more about any of the images, then feel free to ask questions from the guys here, or one of us will be able to help. So thanks again, and refreshments are served.